Okay guys, so good day. So on today's discussion, so this will be just a summary of what we have discussed from the previous video lecture. So again, under session 1, so we have the topic of stress. So before we proceed with the introduction, so basahin muna natin itong nasa taas. So this is just a new addition para sa ating workbook. So sabi dyan, stay positive, work hard, and make it happen. So, naglagay tayo ng mga inspirational quotes para at least maging motivation nyo habang nagsasagot kayo ng mga problem sets. Alright? So, again, stay positive, work hard, and make it happen. Alright, so introduction to the 3 fundamentals areas of engineering mechanics are the following. So, under engineering mechanics, ito yung nakapaloob sa kanya. So, the first one, which is our subject last semester. So, that is the statics of rigid bodies. So, ang ating rigid bodies is nahati sa dalawa. 2 division. So, under that, meron tayong yung SRB nga, which is the static of rigid bodies. And we have also the dynamics of rigid bodies. And another area under the engineering mechanics is yung ating mechanics of materials. So, ito yung isa sa tawag sa kanya. Mechanics of materials. Aside from that, mas kilala ito sa tawag ng mga estudyante nung una, and even in other school. So, meron silang subject na tinatawag na strema. So, strema stands for, so this is the strength of yung materials. Ito yung tawag sa subject namin na yan dati. Strength of materials. So, ngayon, under new curriculum, so, ang tawag na natin sa kanya, dito sa subject na mechanics of materials. So, ang tawag ngayon sa kanya is yung mechanics of deformable bodies. Okay, so this core subject ay iikot dito sa mechanics of deformable bodies. So, basahin natin. Again, definition natin before, under nung sa statics and dynamics. So, this is devoted, these 2 areas is devoted primarily to the study of the external effects upon rigid bodies. So, bilugan ko lang yung rigid bodies. Ayan. So, main concern natin dito ay yung mga external force and then yung magiging effect niya on a rigid bodies. That is, bodies for which the change in shape, yung change in shape niya or yung deformation can be neglected. So, ito yung sinasabi ko sa inyo before during the course orientation na even though gaano ka laking load yung kinakaya ng isang object or yung isang particle, hindi natin siya i-consider na magkakos ng any deformation. Rigid siya. So, kahit gano'ng kalaking load yan, kahit gano'ng kagaan, walang mangyayari sa kanya. Yung pa rin siya. Kung ano yung shape niyan before, yung pa rin yun. Meanwhile, under sa mechanics of materials, or the mechanics of deformable bodies. So, this area deals with the internal effects and deformations that are caused by the applied loads. So, based on the externally applied load, ang pinag-aaralan natin ngayon dito is yung magiging internal effect niya. Internal effect on a specific section or region ng particle or object na ina-analyze natin. And because of this externally applied load, so only possible, magkaaroon ka na ngayon ng deformation. Before kasi under SRB, ina-assume natin na yung deformation niya is sobrang liit na inineglect na natin siya. Pero dito, under mechanics of materials, kahit gaano kaliit yan, we need to consider that, especially when designing a part of a machine or any structure. Okay? So, both consideration are a paramount importance in design. So, yun nga. So, a machine part or structure must be strong enough to carry the applied loads without breaking and at the same time, the deformations must not be excessive. So guys, ito kasing pagdating nyo ng structural theory or do sa last part ng core subject na to, I don't know if matatakal natin, pero meron kasing topic dyan na merong deflection. So it doesn't mean naman na meron kang deformation or meron kang deflection na nangyari. Hindi na safe yung isang structure. So meron siyang allowable deflection na tinatawag. Again, it will be tackled out sa mga susunod nyong subjects. Okay? So let's proceed with the next discussion. So under 1.2. Ayan. So, analysis. Baba ko lang saglit. Analysis of internal forces. So, under stress. So, in mechanics of materials, we analyze to determine the internal forces. Ayun nga. Determine the internal forces. That is, forces that act on cross-section that are internal to the body itself. Okay? So, just like for this figure, under figure 1.2, so this represents the external forces acting on a body. So, meron tayo ditong body. So, this is in the shape of a S-shaped section. Ayan. So, kung mapapansin nyo, meron tayong mga forces dyan na naka-applied, externally applied load. So, we have F1 going in this direction. We have also F2. We have also F3. And we have also F4. Okay? So, ang sabi nga dyan, internal forces that act on a cross-section that are internal to the body itself. So, that section under the body is represented by this number 1. So, napansin nyo yung 1, nag-section siya dito. And ano yung shape na nabuo sa section natin? Diba, as you can see, circular section yan. Tama ba? So, lagi pala tong... Teka lang ha. Tulak. Ayan. Circular section. So, again, because of this externally applied load, nag-cause siya ng internal reaction dito sa section 1. Okay? So, yung circular section na yan, so sa formula ng stress, so later on, i-discuss pa rin naman yan, na P over A, so yan yung area natin, yung cross-section ng area, or yung section ng body na ina-analyze natin. Alright? So, only after this computation have been made, can the design engineer select the proper dimension for a member and select the material from which the member should be fabricated. Okay, so based on this analysis, so ito nga yung nagiging factor para kay design engineer kung anong section yung gagamitin. Again, may allowable stress kasi na ibibigay sa iyo na from which yun yung kailangan mo masatisfy para malaman kung ano ba yung shape na most applicable para sa scenario na to or sa case na to or ano bang type ng materials yung gagamitin natin. So, bawat material kasi meron siyang mga specific property. So, for example, meron kang steel bar and meron kang wood. Considering na same dimension yan, so, alin ba dyan yung mas kaya mag-carry ng load? Alin dyan yung mas kaya mag-carry ng stress? So, di ba? Based on the material properties, so mas kayang magdala ng load nitong si steel compared dito kay wood. Okay? And yung steel natin, meron siyang iba't ibang yield strength pa din na tinatawag. So, mapapansin nyo nga, di ba, kapag may mga delivery ng bakal, for example, sa hardware or in a construction site, so, mapapansin nyo sa dulo niyan, may mga color coding kasi yan. Di ba, merong sa dulo ng steel rod nyo, meron siyang color green, minsan kulay pula, minsan kulay blue, puti. Ayan. So, may color-coded yan based on its yields. Okay? So, again, under figure 1.3a, so ano ba yung sinasabi nito? So, kapag nag-section ka, so maalala nyo, di ba, pag nag-section, it's either i-consider natin tong upper portion Ito. Or pwede rin natin i-consider itong lower portion. So nagkataon lang on this figure, ang kinonsider is yung upper portion. And as you can see dito sa center ng inyong section, which is a circular shape, nagkaroon siya ng internal forces. So nandyan papasok si R, which is going in this direction. And meron kang C raised to R. Or this is a couple. Okay? Couple moment. Kung maalala doon sa subject natin. Okay. So as we lower down, yung R kasi natin. So if you're going to resolve yung R, which represents the resultant force caused by the externally applied load, meron kasi siyang dalawang component. Okay? So, assuming that this is acting at a certain angle theta, diba? So yung P mo can be solved as R cosine theta. And yung V natin, or the shearing force, represented by V. So, ito ay magiging R sin theta. Ayun. So, kinukuha lang natin yung component ng resultant R. So, napalabas natin yan. Ano? So, it is conventional to represent both R and C raised to R. So, pa-correct na lang nito. In terms of two components. One, the perpendicular to the cross-section. So, when we say perpendicular, again, it will produce 90 degrees. Okay? So, lying in the cross-section as shown in figure 1.3 B and C. Okay? So, etong C raised to R, yung couple nga natin, nahatiran siya into its two component. So, meron kang tinatawag na torque, which is represented by capital letter T. So, this double head arrow, so ang nire-represent kasi niyan is a moment. Ano? So diyan papasok yung right hand rule. So later on naman i-discuss natin yung right hand rule. Pero yung concept niya is same lang din do sa topic natin, do sa force system in space. Ano? Para malaman mo kung kailan positive or negative yung moment. Okay? So, and yung kanyang parallel component with respect to sa cross-section is represented by the symbol M. So, yung M natin, so that represents as the bending moment. So, from the term itself, bending, it causes the section to bend. Ano? So, these components are given the following physically meaningful names. So, i-define natin kung ano-ano yung mga forces na yan. So, unahin natin siguro yung P. So, again, ano ba yung P natin? Based on the diagram, this is the perpendicular component of the resultant R. So, P is the axial force. The component of the resultant force, ayun nga. So, that is perpendicular to the cross-section. So, this force P tends to elongate. So, when we say elongate, so, hinihigit niya. Or that is in tensile force, which tends to elongate or pahabain yung iyong section. Or to shorten the bar. So, kapag shorten, compressive siya. So, this is also known as the normal force. Pero guys, on some books, this normal force, isa pang tawag sa kanya, pwede mo siyang i-define as your axial force. What else? This can be also represented or called as the normal force. Ay, yun na pala yun. Normal force. And again, this normal or axial force is can be represented into two. So, meron tayong two types niyan. So, we have the tensile force and we have also the compressive force. And kapag hindi mo i-define siya as tensile or compressive, so again, kagaya before, analysis of structure, yung tensile force, ina-assume natin siyang positive, and then yung compressive force, so that is negative. Doon sa sign convention niya. Pero kahit lagyan nyo na lang sa dulo, di ba? Sa before, nilalagyan natin ng T at saka C. So that is understood naman. That is a tensile stress or compressive stress. So, itong force P na yan, it will cause the normal stress dun sa ating body. So, for this example, yung S bar nga natin. Okay, next component. So, we have the V. So, the V is the shearing force. So, the component of the resultant force lying in the plane of the cross section. So, when we say lying, that is parallel do sa direction ng iyong cross section. Okay? So, ayan nga, kung makikita nyo dito, so, yung shearing force mo is in the same, or, that is parallel. When you say parallel, it's either pa ganyan yan, or pa ganyan. Pwede naman pa kaliwa, pa kanan. Basta ang tendency niyan, just to make the story short, dapat nag-iisa-isan lang. Shearing nga eh. Okay? So, it's either pa ganyan yan, pa ganyan, pahilis, as long as parallel yung yung direction ng force with respect to sa face or do sa section na ina-analyze natin. Next, we have also the T. Again, yung T natin. So, that is just the torque. So, define natin what is T. So, this is the component of the resultant couple, yung C raised to R nga natin. So, that tends to twist or to rotate the bar is called the twisting moment or torque. So, another definition pala or another tawag for torque is the twisting moment. So, from the term itself, twisting moment, so tinitwist niya. So, for example, ito yung bar natin. So, it's either pa ganyan yan, di ba? So, yun nga yung T natin eh. So, it's either represented ka ng pa ganyan or pa kabila. So, twist. So, yung moment mong ganyan, parang pinipilipit niya yung So, kung mapapansin nyo, parang hindi naman parang nag-twist talaga siya. So, ano ba yung yung kinakain natin ng bata, yung marshmallow na twist. So, parang ganun yung concept niya. Twisting. And this twisting moment or torque, eto, dyan papasok si torsional stress. Okay? So, that is, again, another topic. I think that is module 3. Under module 3 natin. Twisting moment or the torsional stress. And last, we have the moment or yung bending moment, which is represented by the symbol, capital letter M. So, this is the component of the resultant couple that tends to bend the bar is called the bending moment. So, again, by the definition itself, bending moment, for example, ito yung bar. So, ang iyong torsional stress is going in this direction. It's either pa ganyan yan or pa ganon. Yung bending moment naman, it's either pa ganyan yan, which, ayan yan, kung mapapansin nyo, na bend. Pwedeng pababa, pwedeng paaliwa, pwedeng paanan, pwedeng pahilis. Ayan. Basta mangyayari dyan, parang binebend niya. So, yung M naman na yan, gagamitin natin yan, guys, sa pag-compute ng bending stress. So, those are stresses in beams. So, sa padulong part yan. So, that will be the last topic if hindi natin matatakal yung topic na deflections. And so, to further illustrate, ito pala, may diagram palang pinakita dito kung ano yung nangyayari. Based do sa mga component nga ng mga internal force na yan. Ito yung mangyayari do sa ating bar na ina-analyze. So, this is the undeformed state. So, when we say undeformed state, walang nangyari sa kanya. Yan yung original shape niya. Yung mga forces na ina-analyze natin kanina, hindi pa naka-applied. So, again, yung force P natin. So, itong P na to, so, dinemonstrate nyo siya as a tensile force P. So, originally, ganito lang yung length. Ayan. So, ito lang yung length, original length ng iyong bar. But because of this axial force P, yung L mo nadagdagan ng certain deformation. So, mas humaba. So, Again, yung axial force, meron pa siyang isang klase. So, ganito naman yung magiging itsura niya kapag compressive force yung in-apply natin. Ano? So, anong nangyari lang naman dito? So, ito, kung mapapansin niyo yung axis niya, kapag ginawa mo siyang compressive force, mas naging dikit-dikit siya. Ano? So, yung axis na yan, nire-represent na yan, nag-elongate. Kung mapansin niyo dito, yung gap dito is lumaki. Ano? Compare dito. And then, if the original lang is L, ngayon naman, ibinawas mo yung deflection. Ano? So, mas lumiit yung ano natin. Yung rod. Next, for the shearing force, ayun nga. Sliding action. So, nag-iis-isan. So, since pa ganito yung shearing force, so, masan nyo, medyo tumaas. Parang tumaas yung rod natin. Ano? Next, for the twisting moment or yung torque nga na tinatawag. So, kung mapapansin natin, initially, pantay yan. Diba? Kaya ngayon, because of this twisting action, coming from this position, anong nangyari? Yan. Nagkaroon ka ng angular deformation or meron ka ditong theta. So again, itong theta na to, that will be discussed pa rin naman doon sa mga susunod na topics, particularly in the topic of torsional stress. Ito yung version ng deformation dito sa axial stress, yung normal, yung mga simple stress pa natin. Parang ito yung counterpart niya pagdating doon sa torsional stress. Okay, so ano ba yung dimension ng stress natin? Ano yung unit ng stress natin? So that is represented by the unit of force over L squared or the length squared. So again, yung L squared natin, so that is just the area. So pwedeng meter squared yan, pwedeng inches squared, depende sa unit. Ano? So again, you need to review pa rin or recall the conversion from SI to English units. So in English, in SI units, the force is measured in newtons. So I know you're very familiar with Newton. So pwedeng kilonewton yan. Ayan. And area in square meter. So ito, yung Newton per meter squared. So that is represented by the unit of Pascal. Okay? Ayan nga. Inano naman dito. So in US customary units, force is measured in pounds and area in square inches. So the unit of the stress is in pound per square inch. Or siguro mas kilala nyo sa tawag na PSI. So again, meron siyang isa pang version which is the PSF or the pound per square inch. Pero wag din kakalimutan yung mga KSI because this is a common unit also of stress pa rin. So nangyari lang naman dito, so kilopound per square inch. So ayun, minultiply mo lang ng 1,000 or divide. So the commonly used sign convention for axial force is to define tensile forces as positive and compressive forces as negative. So ito nga yung na-discuss natin kanina. And the first two equations na gagamitin natin, ito. So we have the normal stress or axial stress, which is denoted by the symbol na sigma. Okay? Is equals to the P, the axial force P over A. And we have the shearing stress, which is represented by the symbol na tau, or yung pinasosyal na letter T. So that has an equation of shearing force V over A. So nagkaroon lang ng konting distinction para at least ma-distinguish nyo kung alin si P, kung alin yung axial force, alin yung shearing force. So pag shearing force, B siya. And kapag normal force, that is represented by P. So ito sometimes on other book, F yan. Pero again, kayo naman kasi ang bahala dito kung anong symbol yung gusto nyo i-represent sa kanya. As long as do sa una pa lang, i-define nyo kung ano siya. Kung V, that is the shearing force with the value of ganyan-ganyan. So this convention is carried over to normal stresses. The tensile stresses are considered to be positive, compressive stresses as negative. A simple sign convention for shear stresses does not exist where A is the area of the cross-section. So again, yung cross-section mo, yan yung A. So again, ang A is unit of an area. Alright? So let's proceed with the next discussion. So these are stresses on inclined plane. So, ayan. So, kung maalala nyo before do sa topic natin mga inclined surface, same concept lang din naman siya. So, basically, yung principle na i-apply nyo dito is trigonometry. So, dapat lang ma-identify nyo kung kailan siya magiging sine or cosine. So, again, kapag mga inclined, ano nga yung diskarte natin kapag inclined? Tagilid mo rin yung ulo mo para mas madali mo siyang ma-analyze. So, just like here on this example, so when a bar of cross-sectional area A, ayan, so kung sisilipin mo siya from this view, so kung sisilipin mo siyang pa ganyan, ano ba yung makikita mo sa top? So let's just say na ito ay the shape of a square. So yan yung cross-section natin. Ano? So yung P mo, ito siya, acting in tensile direction. Okay, so ayan, ito yung area. Yung shaded part, yan yung area po natin. So the normal stresses PA acts on the cross-section of the bar. So as you can see here, itong ating section AA, so naka-incline siya. Okay? So kung isa-section mo siya, and i-analyze mo yung internal forces acting on this part, so mahati siya into two components. Kasi inclined surface nga eh. Or if you're going to analyze the stress acting on this inclined surface, particularly, ayan. So, ito yung force P mo. So, nangyari sa kanya, it is acting inclined at a certain degree, theta. So, again, definition nga natin, yung normal force P mo, o yung normal force or the actual force should be perpendicular. Eh, hindi ka naman perpendicular dito sa inclined surface eh. That's why you need to get this component. Ano? And same as for the shearing force V. So ito yung V mo eh. Ayan. So dapat parallel ka do sa section na ina-analyze mo, which is itong section AA. Naka-inclined eh. So, dapat acting on the same direction. Ayan. So, yan yung shearing force V mo. So, to get that component, ayan lang, simply to get the perpendicular component of P, so that is P cosine theta. And para do sa parallel component, so that is just equal sa P sine theta. So, again, kapag nalilito guys, tagilid mo lang yung ulo. Okay? And this shearing force will cause a shearing stress of tau. Ayan o. So, yung shearing stress is acting in this direction. Again, parallel siya. Which is, ito equals sa shearing force B na P sine theta. And then, etong inclined area na yan. So, paano ba natin makukuha yung inclined area na yan? Okay, so if itong shaded area is A, ayan. So kung A yan, kung ito yung A, di ba? Ayan kasi yung A mo. Ang kailangan natin makuha is ito. Burahin ko lang So i-represent na lang natin siya as our A prime. Okay? So, wag masyado malilito. So, ano ba yung na-form natin dito, guys? Diba naka-form tayo in the shape of a triangle? So, dyan lang di papasok ulit yung ating trigonometric function. So, ano ba yung trigonometric function yung gagamitin mo to solve for A prime? Again, A prime yung kailangan nating area, ha? Okay? So, dito, ang mangyayari, so that is P. Etong, ano ba to? Dapat ito yun eh. P cosine theta over A prime. And para sa shearing stress, so that is your shearing force B, which is P sine theta over the inclined area. So, paano natin makuha yung inclined area? Tama. So, by using the trigonometric function na cosine theta. So, di ba yung A prime, parang naging ano siya, yung hypotenuse. So, A over A prime. Or in short, yung A prime mo is just equal sa A over cosine theta. Ayan. So, kung mapansin nyo dito, ayan siya. A over cosine theta. So, tinaas niya lang. So, the final equation is P over A cosine squared theta. And for shearing stress, so, nung tinaas niya yun, sin theta, cosine theta. Diba, kung maalala nyo yung trigonometric identity natin, yung sin 2 theta is equals to 2 sin theta, cosine theta. Kaya ang ginawa niya, nag-divide siya dito ng 2. Okay? So, kahit ito na lang yung sa ulo mo. Ano? Dito kasi niya, ginamitan niya lang ng trigonometric identities na ganito. Kaya nag-divide siya ng 2 para masatisfy niya itong ano. Pero guys, ito, as long as alam mo yung definition ng shearing stress at saka normal stress, kahit naka-inclined surface yan, hindi naman kasi laging ganito eh. Ano? So, ano lang, basta alam nyo na kapag normal stress perpendicular yung force na i-analyze at the same time yung area if naka-incline yung surface. And for the shearing stress, parallel. Ano? So, yun lang yung dalawang anong kailangan mo. Kapag normal, dapat perpendicular. Kapag shearing is isan, parallel siya dapat. Right? So, ito kahit di mo sa ulo, as long as alam mo yung concept na yun. Pinakita lang dito kung paano diniderive yung equation na yan. Okay? So, pinakita naman natin kung paano naging derivation. Kaya naging ganito yung equations. Okay? So, let's proceed. Ayan. So, procedure for stress analysis for an actually loaded member or the actual stress. So, ito yung step-by-step procedure. In general, the stress analysis of an actually loaded member of a structure involves the following step. So, the first one is the equilibrium analysis. So, ito yung part ng SRB. Yung equilibrium of force system. In order to find the external reaction, if necessary, so use a free body diagram. Ayan. Gawa ka ng free body diagram para sa entire structure. Tapos, after mo magawa ng free body diagram, ang susunod, yun. So, principle of equilibrium of force system. So, again, we have 3 equations to use. Ang walang kamatayang summation of forces X, summation of forces Y, and summation of moment. So, kapag equilibrium, all of these are equal to 0. So, again, kaya nang bahala maglagay dito ng direction. Pero, ayun nga, yung tinuro kong technique, ako kasi depende sa unknown, kaya magko-control ng direction. Pero, typically, paanan is positive, pataas is positive. And clockwise here is positive. Alright, so through the use of method of section, compute the actual force P in the member. So, nagsasection ka lang, ano? So, kung rad yan, pero ang force P dito. So, kapag nagsection kang ganyan, ang pinutol mo. So, ang hinahanap mo kasi, for example, hanapin yung stress dito sa section AA na to. So, nung pinutol mo yan, puputulin mo rin dito. Ngayon, ano yung magiging epekto ng externally applied load P na to dito sa internal o do sa loob ng isang object na ina-analyze natin, which is the rod. So, ano yung magiging stress na na-develop dito sa section na to? So, di ba, yung shaded portion na yan, yan yung area. And then, kung meron ka ditong force P na pataas, and then dito, meron ka ding force P na pababa. So, going in outward direction, that force tends to elongate the bar. So, this will be classified as a tensile stress. So, I hope nagkaaroon na ng idea. So again, kailangan natin si SRB para maging ma-compute yung mga internal effect nito sa portion dun sa object na kinukuha na natin ng stress. So paano mo ba i-compute yung force dito? For example, F muna yan. Di ba, just take summation of forces y equals to 0. So yung F mo, equals lang siya doon sa P. Ayan. Okay, so, ayun nga, through the use of method of section, compute the actual force P in the member. This introduces an imaginary cutting plane that isolate a segment of the structure. Just like what I did. This must include the cross-section of the member of interest. So, hindi naman siya limited lang sa circular. Marami pwedeng shape yan. So, before, kung maalala nyo, di ba, most commonly used shape naman pag mga steel structure is W section or yung I shape. So, the actual force acting in the member can be found from the free body diagram of the isolated segment because it now appears as an external force on the free body diagram. And the next, for the computation of the stress, after the actual force has been found by equilibrium analysis, the average normal stress in the member can be obtained from the equation sigma is equals to P over A, where A is the cross-sectional area of the member, the cutting plane. So, kung ano yung section na kinat mo, yun yung cross-section ng A. Co-consider natin. Ngayon, kung inclined yung pinapahanap, pwede yung naka-inclined na cross-section. Okay, so let's now consider the design consideration. Ayan. Kunin ko lang yung highlighter natin. So, for the purposes of designing, so kapag nagdi-design ka, so the computed stress, ayan, sometimes called as the actual stress. So, yung na-compute nating stress during dun sa actual na nangyari. For example, etong rod na to is nagke-carry ng load P. Ano yung stress na na-develop? Yun yung actual stress na sinasabi natin or yung computed stress. Actual, ito yung nangyayari do sa scenario na yun. Okay? So, this computed stress must be compared with the allowable stress. Or yung allowable stress is, tawag din sa kanya minsan, is yung ating working stress. Okay? So, working stress is equals lang sa allowable sa allowable stress. Okay? So, ang sabi dyan guys, the working stress which we denoted by sigma sub W, so nakasub yan, is discussed in detail in the next chapter. So, to prevent the failure of the member or system, the computed actual stress, so yung actual stress natin guys, compute nga based on the applied load during that time, should be equals or less than the working or the allowable stress. Okay? So, ayun nga, sabi nga kasi, ito lang yung allowable stress ko. For example, lagyan natin ng value. Yung allowable stress or yung working stress na kaya niya is limited lang to 100 kilopascal. Ngayon, ang sinasabi kasi dito sa design consideration, dapat yung actual stress mo is less than lang or equal sa 100. Kasi guys, kapag nag-exceed yan sa 100 kilopascal, so sabi nga, ito nga lang yung allowable, ito lang yung kaya ko 100 kilopascal. Ngayon kung sosobra ka ng county dyan, 100.1, ano yung makakonclude nyo doon sa system? Ano possible na mangyari sa system if lumampas ka doon sa 100 kilopascal? Tama. So sabi nga dyan, system will fail. System if fail. Mali. Typo. So, the system will fail if the actual stress is greater than the working stress. Okay? So, ito is isa sa mga pinakamahalagang consideration. So, tandaan that dapat yung actual stress should be equals or less than dun sa allowable stress para ma-consider siya na safe. Ngayon, if na-violate nyo yung rule na yan, if yung actual stress mo will be greater than the allowable, therefore, that is not safe. or your system will definitely fail. Okay? So I hope we're clear on that. So let's proceed with the next part of the discussion. Alright, so this time guys, we're going to discuss naman yung tinatawag nating shearing stress. Alright. So guys, shear stress, ayun pala, isang tawag doon, is tangent to the plane on which it acts. So tangent to the plane. So shear stress arises whenever the applied loads causes one section of a body to slide past to its adjacent section. So again guys, ito yung isa sa tandaan yung word. So it tends to slide past its adjacent section. Nag-iis-isan, sliding action. Okay? So tama nga naman, tangent. So, di ba pag tangent, ayan, lumapat. So the internal force to be considered is the parallel component of the force. And ayan, this keyword na parallel. So in the figure shown, pinakita dyan yung tatlong cases ng ating shearing stress. So on figure A, so this shows two plates, ayan, meron kang dalawang plate which are joined together by a rivet. So yung rivet natin, yung parang pinaka-tornilyo dyan, eto yan. Ayan. So highlight natin. Ayan. So as seen in the free body diagram, ayan. So nung kinuha natin yung upper plate na yan, di ba merong externally applied load P. So the rivet must carry the shear force. So syempre, naputol dito yung rivet mo. So kung merong amping na going in this direction, syempre, yung internal force na nararamdaman o yung internal reaction na nararamdaman ng rivet based on this externally applied load P, which is going in this direction, paaliwa. So yung shearing force B mo is equals lang sa P. So paano natin nakuha yung anong yan? So assuming na yung V mo is still unknown, so anong equation yung gagamitin natin to solve for the V? Tama. So just by taking summation of forces X equals to 0. So yung V mo, so di ba magiging minus P. Transpose mo sa kabila. Kaya naging ganyan. Alright, so as seen in the free body diagram, the rivet must carry the shear force V, which is equals to P. And because only one cross-section of the rivet resists the shear, so nung nag-section ka, so usually naman yung shape ng rivet mo, kung titingnan mo siya dito, i-zoom ko lang ha, para at least na kita na ayos. Ito kasi yung area na kailangan natin consider. Linaw, no? Ayan. So kung titingnan mo siya sa top view, ito siya, di ba? Parang, ito rin yun. Circular section yun. Or in the shape of a circle. Ayan. So since single lang o isang side lang ng rivet yung naapektuhan, that's why this will be classified as a single shear. Ayan. So mamaya malalaman nyo kung kailan nagiging single shear tsaka kung kailan nagiging double shear. Yung example letter B o yung cleavise na tinatawag, this is an example of double shear. Okay. So, ayan. Single shear. So, highlight lang po natin ito. Ngayon, under figure B, this one, cleavise. So, ba't ba siya tinawag na cleavise? Ayan, meron kasi dito letter C. Minsan Yorkie din itong ano. Basta, figure B shows a cleavise which carries the load P. Ano? That carries a load P, magkabilang direction. Across the two cross-sectional areas, resulting the shearing force being V is equals to P over 2 on each cross-section. Therefore, the bolt is said to be under the state of double shear. Okay, so for this example, Ang i-consider kasi niya is itong lower portion. Eto. Mamaya papakita ko na it will result in the same equation if yung upper part ng cleavise yung i-consider natin. Okay, nung pinutol niya yan, so syempre, yung iyong rivet, etong nagko-connect sa kanilang dalawa. Ayan. So, naputol yan. Ngayon, ito kasi will undergo double shear. Kasi kung mapapansin nyo dito, di ba? Naputol siya dito, naputol rin siya dito. Ayan. Ayan, tsaka ayan. So, meron ka dito, in short, na dalawang V. So, assuming na hindi pa natin alam to, ayan. So, paano ba natin mas kukuha yung value ng iyong shearing force V? So, ayun, tama. Mag-summation ka lang ng forces Y, assuming in upward direction as positive. So, since dalawa yan, so 2V is equals to P. Therefore, the shearing force is just equals to P over 2. Okay? So, if that is the case, ayan. So, this will undergo double shear. Kasi ayan. Dalawa yung shearing force na i-consider. Ngayon, if yung upper portion naman yung i-consider mo, guys. So, kung ba pwedeng i-drawing? Teka lang ha. Dito na lang. I think kasya pa dito. So, kung yung upper part or yung naka letter Y or C, yung i-consider, di ba meron ka dito na force P? Tama? Ngayon, di ba andito yung iyong rivet. So, syempre, meron ka dito. And, meron ka in this portion. Okay? So, parang ganun lang din yung nangyari, di ba? Kung meron ka ditong shearing force V, ayan. So, pareho lang ng kakalabasan. Ano? Tama, naging equilibrium lang eh. Nagkabaligtad lang yung direction. So, ganun. Okay? And, therefore, the bolt is said to be under the state of double shear. So, sometimes yung rivet na yan, that can be classified also as a bolt. Yung highlighter. Okay? Next, doon naman sa sunod, ito naman can be classified yung sa punching stress. Okay? So, imagine nyo na lang, meron kang puncher. Or one good example of this is yung piso. Mas madali mo siyang ma-analyze or ma-imagine if i-represent mo sa itong case na to, na yung piso ba, para nagbubutas ka ng piso. So, in the figure C shows a circular slug to be punched out of a metal sheet. Here, the shear force is P, which acts on the perimeter of the puncher, and the shear area is similar to the milled edge of a coin. So, yun yan, sinabi naman dyan. So, yung area na shear, undergo shear, is similar to the milled edge of a coin. Kita nyo yung gilid ng piso or any coin, yung merong mga linya-linya sa gilid. So, yun yung sheared area for this example. So, anong nangyari dito sa case na to? So, meron ka kasing puncher. Ano? So, ano ba yung mga ano dito? Halimbawa, papel, ayan. Ito yung puncher mo. Ito yung bubutas dyan. So, ito, butasin mo siya. Siyempre, ano mapapalabas mo na shape? Diba bilog siya? Or yung parang coin. Considering na ito yung plate mo or yung metal sheet, meron siyang thickness eh. Ano? Ngayon, kung bubutasin mo siyang ganyan, ayan. O, di ba? So, may lalabas dyan na bilog. Tapos, sa gilid niya, ito na lang, imagine nyo, yung metal sheet, nabutas siya. Okay? So, nung pagkaabutas na ganyan, ayan, drawing natin. So, ito, for example, yung metal sheet. I-isometric ko, ano? Ayan, ito yung thickness niya, di ba? So, let's just say na this is T. Tama ba pa ganito? Kasi ako magaling mag-drawing ng isometric. Ayan. Ayan. So, butas yan. So, dito sa ilalim niya, may lumabas na parang coin. So, sinasabi do sa definition kanina, di ba shearing force parallel? O, if ito yung force P mo, syempre, itong perimeter na to, meron niyang P acting along the perimeter. So, yung mapuproduce niyan, ang total niyan is P lang din. It's going upward. So, ang sheared area niya is itong shaded portion dito o yung milled edge ng coin mo. Which is equals lang sa circumference yan or yung perimeter multiply by the thickness of the coin. Okay? Assuming na ito is radius R. So, ano ba yung perimeter? Paano nga yung pagkuha ng perimeter? Di ba pi d or 2 pi r? So, yung sheared area niyan is 2 pi r multiply by the thickness of the coin. Okay? So, yan lang yung i-divide mo dito sa shear force V, which is yung P natin, to get the shear stress. So, ayan yung shearing stress natin. Okay? So, restart ko lang. Naglalag yung aking... Ayan. So, again na, shearing stress has an equation of shear stress is equals to V over A. So, shear stress can be computed using the above equation where the shear force is denoted by V and is uniformly distributed over the sheared area. Okay, so next type of simple stress is yung tinatawag nating bearing stress. So far, meron na tayong tatlo. Again, i-recall lang natin, guys. Una is the axial stress or the normal stress, which is meron siyang dalawang type. We have the compressive stress and the tensile stress. Pangalawa, we have the shearing stress. Shearing stress, meron siyang tatlong category. Meron kang single shear, double shear, and yung punching action or yung punching stress, kung pwede rin natin tawagin. And then, the third type of simple stress is yung tinatawag nating bearing stress. So, what is bearing stress? So, as defined, yung bearing stress mo is the pressure caused by two bodies. Ito yung palatandaan ko dyan. Caused by two bodies are pressed against each other, compressive forces are developed on the area of contact. So, tandaan nyo na lang, guys, na kapag bearing stress, ito yung contact pressure between the two material. Okay? So, yung isang dimension manggagaling dun sa isa, and then yung isang dimension is manggagaling dun sa isa. So, as an illustration of the bearing stress, consider the lap joint formed by the two plates that are riveted together as shown in the figure below. The reduced area is taken to be the projected area of the rivet. So, for example, ito nga, dalawang plate which is connected by the rivet. Okay? So, yung bearing stress na na-form dyan is itong shaded area dito. Ano? So, again, ang sabi ko nga, this is the contact pressure between the two material. So, yung isang dimension is manggagaling saan? Doon sa plate. So, itong plate na to, guys, meron siyang thickness. Ano? So, yung isang dimension is yung thickness ng plate, this one, and yung isang dimension is manggagaling dun sa rivet, which is yung, eto, the diameter of your rivet. Ayan. So, yung projected area or yung bearing area na i-consider mo dyan, which is denoted by A sub B, is equals lang sa product ng thickness ng plate times the diameter of the rivet. Ayan. The contact pressure between the two material. Okay, so where T is the thickness of the plate and D is represented by the diameter, as I've said, as shown in the figure, projected area of the rivet. So from this free body diagram, we see that the bearing force P sub B, ato, is equals to the applied load. The bearing load will be reduced if there is friction between the plate. So kapag wala namang friction, guys, yung applied load P, hindi na siya mababago. So that the bearing stress becomes, so ayan, ito parang normal stress lang din daw eh. So bearing stress is just equals do sa bearing force over the bearing area, which is equals sa P kapag wala nga friction over T times D. Alright, so that ends the discussion for the simple stress. So next, magsasolve tayo ng mga practice problem. Okay? So, live discussion yun. So, sagutan nyo na guys yung mga practice problem do sa libro. So, next meeting natin, magprepare ako ng problems na tatawag ako from the group para sila yung mag-discuss ng solution na yun. Again, ako yung magko-control. Ako yung magpa-facilitate, tatawag. So, kung di masagutan, ako yung magsosolve. So, dyan papasok yung atin graded recitation. So, everyone is requested to participate. Again, this is 5% of your grade. Alright guys, so that ends our discussion review for this topic, the simple stress. So, see you guys in our next video lecture. Peace out.